All right, welcome guys. This is Bibi, and in today's video, we're testing out this new way of doing our math. Anyways, so we're given the polynomial equation and we're asked to solve for x. We know that this polynomial is of one variable and the highest power is 2 of said variable, so therefore this is a quadratic polynomial. We can solve this easily by doing the following. So we can expand our expression, and by inspecting it, we can find our x's that makes this equation equal to 0. So in this case, we're going to put down our x. Then we're going to talk about two integers, right? So what two integers multiply to get negative 15 and add to get negative 2? Well, 3 times 5 is 15. So now when we add it, how can we get negative 2? So we can add 3 plus negative 5 to get our negative 2. So that means our 5 is negative. So that means we're going to have a negative 5 and a positive 3. So that's going to be 3 times negative 5 is equal to negative 15. 3 plus negative 5 is equal to negative 2. So that's how we would solve this, and then we would say that if x is equal to negative 3 and positive 5, our equation would equal to 0. Now, what if we could not expand our given equation to be able to find our x? So what if we couldn't expand, or what if we couldn't factor it? How we would then find our x? Well, we could use the quadratic formula, right, to solve for that. Now, what if we didn't know that? How can we derive it? In a class, you may ask to derive the quadratic formula. Well, to be able to do that, you want to do the math symbolically so you can see the form of the quadratic equation, right? How do we do that? Well, we're going to use the same problem, right? And we're going to turn that into symbolic equation. So then we're going to say that our a is equal to our coefficient of our x squared. We're going to call that 1. B is going to equal to our coefficient of our x, and that we're going to call that negative 2. And we're going to say c is equal to coefficient of our constant, which is negative 15. Then we're going to replace that. So now we're going to replace the coefficients and the constant of that expression, and then we're going to solve symbolically. So then we're going to get a x squared plus bx plus c, which is our constant, is equal to 0. Now we're going to solve for x. Solving for x, so remember, this is a form that is expandable. We can factor this form. So what we want to do, remember, in this case, we don't know the coefficients and the constant, right? So we would like to make sure we get a coefficient of 1, right here, or we would so if we want to leave a 1 right there, we don't want a value for coefficient, so we want to remove the a. Next thing we want to do is we're going to add a constant. Kind of jumping ahead of the gun, but let me show you what I mean. So separate or group like terms, or variable in this case. We're going to keep our a to one side, our x to one side. So then we move our constant to the left. Now we have our constant to the left, right? This should have been bx, negative c. So our constant is to the left, and we have our x on the left-hand side. Now, when we go back up here and look, right, we can factor this side of the equation, right? Only if, not only, because in this sense, if this was a high coefficient, we might have to have that factor out here. But let's try to get into this form. So we're going to remove our a, and then we're going to try to get a coefficient that we can manipulate to get this expandable. And because we're going to try to get this coefficient to keep this in equilibrium, we're going to have to add this coefficient to each side, right? All right. So basically, we call that completing the square. So when we look at this, we first want to remove a. So we're going to remove our a. So that's going to be x squared. B over a times x is equal to negative c all over a. Right? There we go. So now if we look, we have x squared. We have our x squared right here. We have this coefficient right here, which, yeah, there's a coefficient right there. Now we want to find a constant. And we want to be able to, when we do this, it is expandable. So that means we're going to complete a square. So now to do that, we would like to, in this case, say, okay, how can we do art? Not even thinking about that. If this is a square, a perfect square, right? We could take the square root and then find x, right? So let me show you what I'm talking about. So if I have, as I just said, if I wanted to be in this expression or this form, and I want to be able to take it from this form to this form, but I want this form to be able to be written as one form, square, so one parentheses square. So what I'm trying to say is that I want this expression to look, I want this, we know is going to be equal to x plus n times x plus n. And if I square this, notice what happens is that I get this, right? So if I can get this side of my equation, in this form, I'll be able to square it and get this. And if I get this, I can have my x equal, and then I can put my n over here. So then I would have my x on one side. So to do that, we didn't realize that if we have this form, when it expands, we get this. This is now a perfect square. So all we have to try to do is write this side into a form of such. So now, let's get that done. So we then see that if we expand this, we're going to get x squared plus 2n times x plus n squared. Now, well, no more equal signs. We can realize, if we realize we have the x squared, we have the coefficient right here, but we do not have the constant, which is n squared. How do we find n squared? Well, we can set our coefficient to 2n, right? And then solve for n. So then we can say b all over a is equal to 2n. That means n is equal to b all over 2a. So that is n. So now we have n. The constant, though, is squared. So when we square that, n squared is going to equal to b squared all over 4a squared. Now that we have our n squared, we can add it to this side of the expression to be able to expand into this form. And when we add to this side, we add to that side. So now we have x squared plus b over a times x plus b squared all of 4a squared is equal to negative c all over a plus b squared all over 4a squared. Now, we can expand this or factor, because this is a perfect square, so we can write that as x plus b all over 2a. Well, remember, b over 2a is n, and what we're trying to write it as is x plus n. So therefore, b over 2a And because it's a perfect square, that's going to equal to this side over here. Now, we can simplify this by saying, add both fractions. We can commute this to this side. So we're going to have the positive here and the negative here. So then let's just do it like this. So if we want a common denominator of 4a squared, right? All we have to do is multiply this by 4a. We get a common denominator, then add negative 4ac plus b squared all over the common denominator, right? So then we're going to commute the positive to here, move the negative to the right. So we're going to have plus minus, right? So therefore, we're going to have b squared minus 4ac all over 4a squared. You guys get that? Now, what else do we do? Well, remember we're solving for x. We have x here, so now if we take the square root of that, we then get our x. So we're going to take the square root on both sides of the equation. So then we're going to leave with x plus b all over 2a is equal to plus or minus b squared minus 4ac all over 4a squared. And if you know the quadratic equation, you can already see what's going to happen. So then we can remove, at this point, this is a constant. So we can move our constant over here because this is a constant as well. There's no variables, x, right? So then we're going to have x is equal to negative b, well, you can say negative b all over 2a, whatever you're going to call it, plus or minus b squared minus 4ac all over 4a squared. Now, that is our quadratic equation. We can further simplify that. So how do we simplify? By still writing our negative b all over 2a plus or minus, take the square root of the top, right? ac, right? And the square root of the bottom, 4a squared. 4a squared, we know going to c is going to equal to 2 times a. We see we had two fractions, so then we can add both fractions, right? So that means it's negative b plus or minus square root of b squared minus 4ac all over 2a. And that is a quadratic equation. So now, if we didn't know what our answer was, we can then find out. So we can write the equation again. So the equation was x squared plus, it was negative 2x minus 15 is equal to 0. And by having that, you could plug what you have to find. Remember, a is equal to 1, b is equal to negative 2, and c is equal to negative 15. So by doing that, you then see that the quadratic equation can be solved by the quadratic formula. And if you didn't know, as long as you know how to factor and you know about perfect square and you can manipulate the mathematics, you can then arrive to your quadratic formula. So I'll see you in the next one. Bye.